Okay, let's look here at activity 10-2. And with this one, you're calculating the limits in the first two problems. And that it gives you your basic hole size and allowance and tolerances for shaft and hole. So there's no looking at the charts. It's just information that's given. And in some manufacturing situations, you may have company standard tolerances that don't fit with the chart. Okay, it is possible, it does happen. So the first two, you're calculating the upper and lower limits for each part, the shaft and the hole. And in the second two, you have to calculate that, but then you determine what is the bilateral expression for the plus minus. Okay, and then you would write the dimension as that. So once again, I've got a handy dandy little word chart here that I'm going to work through with you. And so let's look at our first, the example I'm going to give you based on a 1/2 inch shaft, an allowance of 4 thousandths, shaft tolerance of 8 thou, and a hole tolerance of 6 thou. All right, so we start out with our hole, and our most material condition, in this case, is 0.5. Okay, the tolerance for the hole is 0.006. And remember, most material condition of the hole means that's the smallest possible hole. So I add the 0.006 to that, and that gives me with 0.506. I didn't need to put that thousand there. Okay, so that is my hole. All right, so I'll come down here. The hole limits is 0.500, 0.506. Okay, now let's look at the shaft. So we still start out, we have to start with our hole MMC, which is a 1/2 inch. And then we're going to subtract out the allowance. I don't know why that jumped over there like that. Okay, so we subtract our allowance, which is the difference between maximum material conditions. Okay, and so that gives me, what happened to my mouse there? 0.496 is the maximum material condition of the shaft, the largest possible shaft. From that, I can subtract the tolerance of the shaft, which in this case is 8 thou, and that gives me 0.488, which is the least material condition of the shaft. Okay. Maybe I should come in here and put MMC, LMC. And I could do the same over here. Okay, so that way you can see what I've done there. So that gives me my my shaft limits are now 0.488 to 0.496. And so that would be what you would dimension in here. Okay, now the next two down here, you got two different shafts, so you have to solve them in the same way. But what we're looking is to come up with a bilateral expression. And so if I come back to this same problem here, and what I want is I want a dimension that is exactly in the middle of these. I could go up or down either way. And you could just take half of the value here as you're doing this math. So for the hole, what I'm going to end up with is 0.503, and then I don't remember the code for plus minus, 0.003. And then with my shaft, half of the tolerance is 0.004. So that gives me 0.492 plus or minus 0.004. Okay. And so that's how you do this exercise, huh? There you go. If you got questions, send us an email or come see us, okay?